times negative 1/3. So that is our recursive formula. Okay? Yan lang ang pagsusulat ng recursive formula, wherein we use this recursive formula to be able to find out what will be the next term after negative 5/3. Okay, now with the recursive formula, so we can proceed with explicit. Okay, let's have another example on how to write recursive formula of geometric sequence. So for example, we have 10, negative 30, 90, and negative 270. In writing recursive formula or creating a recursive formula of your geometric sequence, the value that you need is the n and r. Okay? Kailangan merong value ni n at merong value ni r, which is r is our common ratio and n is the number of terms. Okay. So the number of terms that we have in our sequence is 4. We have 4 terms in our sequence. So we have 4, and common ratio is the quotient when we divide two consecutive terms from our sequence. So kapag dinivide natin si 30 to 10, negative 30 divided by 10 is equal to negative 3. Okay. So negative 3 is our common ratio. So meron na tayong value ni n, meron na rin tayong value ni r. So we can now write the recursive formula. Substitute the value of n and r in the equation that we have, which is an equals to a sub n minus 1 times r. So we have an equals to a, your n is 4, minus 1, times the value of r, which is negative 3. So the recursive formula of our geometric sequence is an equals to a, 4 minus 1 is 3, times negative 3. So that is our recursive formula. Okay? Okay, paano kung hindi naman 4 ang term? Kasi lahat ng terms na meron tayo dito is 4. Let's have another example. For example, we have this geometric sequence. So for example, yan ang geometric sequence that we have. Okay. So we need to identify what will be the recursive formula of our geometric sequence 4, 8, 16, 32, and 64. Since we're going to write the recursive formula of our geometric sequence, which is an equals to a sub n minus 1 times r. So, kailangan mahanap natin si value r, the common ratio. What is the common ratio of our geometric sequence? Ano ang quotient pag dinivide natin ng consecutive terms in our geometric sequence that we have? 2. So our common ratio is 2 since 8 divided by 4 is equal to 2. So that is our common ratio. Since we have the common ratio and the number of terms that we have here on the screen is 5. So the recursive formula of the geometric sequence that we have is an equals to a, our n is 5, minus 1 times the common ratio that we have, which is 2. So an is equal to a sub 4 multiplied to 2. So that is the recursive formula that we have. Okay na with recursive formula? Okay na tayo with recursive. So we can proceed with explicit formula. Okay. So let's proceed with explicit formula. Okay, so let's proceed in writing an explicit formula to represent the sequence from example 1 and find the 10th term. The first 5 terms of our sequence are 2, 8, 32, 128, and 512. That is our geometric sequence. So we need to write the explicit formula for us to be able to find what will be the 10th term of our geometric sequence. So, kailangan magkasulat muna tayo ng explicit formula. So, to write explicit formula of our geometric sequence, we need to have the value of our common ratio and the value of the first term. Okay. Yan ang kailangan natin for us to be able to write the explicit formula of our geometric sequence. Kung kay recursive, kailangan si n. Kay explicit, ang kailangan is the first term and the common ratio. According to the sequence that we have, which is 2, 8, 32, 128, and 512, the common ratio is 4, since 8 divided by 2 is equal to 4. So that is our common ratio. And the first term is 2. So since we have already the value of the common ratio and the first term, we can now be able to write our explicit formula. Explicit formula of geometric sequence is in a form of an equals to the first term multiplied to the common ratio raised to n minus 1. Since we have the value of first term, which is 2, times the common ratio, which is 4, raised to n minus 1. So, by explicit, in writing explicit formula of your geometric sequence, you're not going to change the value of n or the variable n in the formula. It's still n in writing the explicit formula. After changing or substituting the value of the first term and the common ratio, you have already your explicit formula. So, if you change lang si first term at saka si common ratio, you have already your explicit. So, since we have our explicit formula, we can be able now to find what will be the 10th term of our geometric sequence. So let's find out what will be the 10th term of our geometric sequence using the explicit formula that we have right, which is an equals to 2 times 4 raised to n minus 1. See, 10th term that we're going to solve will stand as the value of n. So an equals to 2 times 4. Our n is 10 minus 1. So we have 2 times 4. 10 minus 1 is 9. So 2 times 4 raised to 9 is equal to 2 times 4 raised to 9 is equal to 524,288. So ito ang ika-10th term of our geometric sequence. Okay? So we use explicit formula in finding a specific term. Why recursive? We use it in finding the next term from the previous term that we have. Okay, let's have another example for explicit formula, writing explicit formula, and identifying the specific term of our sequence. For example, we have this geometric sequence, which is 3, we're going to find the 6th term of our geometric sequence. So since we're going to find the 6th term of our geometric sequence, we need to write an explicit formula for us to be able to solve what will be the 6th term of our geometric sequence. Since we're going to write the explicit formula of our geometric sequence, we need to have the value of our common ratio and the first term. The first term in our geometric sequence is 3. And the common ratio of our geometric sequence is 9 divided by 3, which is also equal to 3. So we have already our common ratio and our first term. So we can now be able to write the explicit formula of our sequence that we're going to use for us to be able to solve the 6th term of our sequence, which is an equals to the first term multiplied to the common ratio raised by n minus 1. So our first term is 3 multiplied to the common ratio, which is also 3, raised to n minus 1. So this is our explicit formula. Okay. So the explicit formula that we have is the one that we are going to use to solve our 6th term. Okay? So let's use to find out the 6th term. Using the explicit formula that we have for our sequence, an equals to 3 times 3 n minus 1. Si n in the explicit formula that we have is the term that we are solving, which is 6. So we have 3 times 3, our n is 6 minus 1. So 3 times 3 raised to 5. So 3 times raised to 5. So we will be having 3 times 243. So 243 times 3 is equal to 729. So that is the sixth term of our geometric sequence. Okay? Mas madaling magsulat ng explicit formula at recursive formula than finding the specific term. Right? You just need to change the value of the common ratio and the value of the first term in writing the recursive formula and the explicit formula of our sequence. Okay, let's have another example in writing the explicit formula of our equation or our sequence. Okay, now with this example, can I clear the screen? Okay. So for example, we have this geometric sequence. Okay. So for example, that is our geometric sequence, and we need to find the sixth term of our geometric sequence. So since we're going to solve for the sixth term of our geometric sequence, we're going to write first the explicit formula of our geometric sequence. So writing the explicit formula, we need to have the value of the common ratio and also the first term. The first term of our geometric sequence is 10. And the common ratio, what's the common ratio of our sequence? Yes, Chloe? 2. That's correct. The common ratio is 2 since 20 divided by 10 is equal to 2. So we have already the common ratio and the first term that we're going to use to write the explicit formula of our geometric sequence. So an equals to the first term multiplied to the common ratio raised to n minus 1. So change the value of the first term and common ratio. So we have 10 multiplied to 2 raised to n minus 1. So that is our explicit formula. Okay, ganyan lang ang pagsusulat ng explicit formula ha. You just need to change the value of the first variable, first term, and the common ratio. So since we have the explicit formula of our geometric sequence that we have here on the screen, that is what we're going to use to find the sixth term. So an equals to 10 multiplied to 2 raised to n minus 1. So we have 10 times 2. N is equal to 6. Since that is the term that we are going to solve. So 10 multiplied to 2 raised to 5. So 10 times 2 raised to 5, 32. So 32 times 10, we have 320. So that is the sixth term of our geometric sequence. Okay, clear with the explicit formula and the recursive formula? Baka nalito na si recursive. Ganito kay recursive ha. Baka pagbalik na rin si explicit at saka si recursive. Okay? Si recursive, the only thing that you need to recursive is the common ratio and the n. Okay? Si common ratio at saka si n ang change natin kay recursive formula, which is an equals to a sub n minus 1 times r. Yan si recursive. Si explicit, the explicit formula, the one that we are changing, is the common ratio and the first term. And an equals to the first term times r raised to n minus 1. Okay? For example, in the recursive formula, if our geometric sequence is 6, for example, that is our geometric sequence. The common ratio of our geometric sequence that we have here is 2, and the number of terms that we have is 3. If we're going to write the recursive formula of this sequence, we have a 3 minus 1 times 2. So the recursive formula is an equals to a sub 2 times 2. Okay, that is our recursive. But if we're going to write the explicit formula with the same sequence that we have, the common ratio is the same, which is 2, and the first term is 6. So an equals to 6 times 2 raised to n minus 1. Yan si explicit formula at saka si recursive formula of our sequence 6, 12, and 24. Huwag papalitan ha, huwag i-interchange si recursive at saka si explicit. Si recursive, you're using it to find what will be the next term to 24. Okay? Yan ang ginagamit natin to find what will be the next term from the previous term that you have in your sequence. While the explicit, we use explicit in finding the specific term. For example, if you're going to find the 10th term, that's specific. Okay? We use the explicit. But if you're just going to look what ano ang magiging next term sa 24, you're using the recursive formula. Okay? Wherein kahit hindi nung gamitan si recursive, mahahanap kung anong next kay 24 by means of using the common ratio. Okay? Okay po, with the explicit and recursive. Okay, let's have an example. In writing the explicit and the recursive formula of our geometric sequence, so for example, we have the geometric sequence 2, 8, and 32. And we're going to write the recursive formula and the explicit formula of our geometric sequence. So kung isusulat natin both formula of our geometric sequence, let's start with the recursive. So we need to have the value of the common ratio and the value of n, wherein the common ratio is 4, since 8 divided by 2 is equal to 4. And the number of terms that we have is 3. Tatlo lang ang terms na visible in our sequence. So our recursive is an equals to a sub n minus 1 times the common ratio. So n is equal to 3 minus 1 times the common ratio, which is 4. So we have an equals to a sub 2 times 4. So that is our recursive formula. What does a sub 2 stands for? Si a sub 2, okay, is the previous term of your geometric sequence. Looking at the geometric sequence that we have, the previous term is 32. So para mahanap kung anong next kay 32, 32 times 4, that will be your next term using the recursive formula. While if we're going to write the explicit formula of our geometric sequence, we need to have the value of the common ratio and our first term. So common ratio is the same, which is 4, and the first term is 2. So an equals to the first term times the common ratio raised to n minus 1. So an, first term is 2 times the common ratio 4, n minus 1. So that is our explicit formula. Okay? So madali lang magsulat ng recursive and explicit formula of our geometric sequence. So for example, since we have already the explicit formula of our geometric sequence, we're going to find the seventh term of our sequence. So since in the problem, it's being mentioned that we need to find the seventh term, ang gagamitan lang is si explicit. Hindi pwedeng gamitin si recursive. Okay? When you're finding the seventh term of whatever number of terms in the sequence, you're not going to use the recursive formula. You always use the explicit formula. Given that we have already the explicit formula of our geometric sequence, so we have an equals to 2 times 4. Our n is 7 minus 1. So 2 times 4 raised to 6. So 2 times 4 raised to 6 is equal to 2 times 4096. So the seventh term of our geometric sequence is equal to 8192. So that is the seventh term of our geometric sequence. Okay. Si recursive, kung ang hinahanap lang anong magiging next kay 32, you can use recursive. Okay. So that's the difference between explicit and the recursive formula. Okay, let's try to find this specific terms in the given geometric sequence that I'm going to write on the screen. Can I clear the screen with this one? Okay na? Okay. So for example, we have this geometric sequence. Can you try to find what will be the eighth term of our geometric sequence?